This is the solution to fluids review problem 1000. In a famous 1887 Michelson-Morley experiment, a disk made of sandstone, density 2710 kilograms per cubic meter, that was 1.8 meters in diameter and 25 centimeters thick, was floated in a 1.9 diameter pool of mercury, density 13,560 kilograms per cubic meter, and the pool was 20 centimeters deep. The giant floating stone disk could spin with nearly no resistance when pushed. What is the total force pushing on the ground? So in this problem, the total force is the sum of the two weights. First, I'll have the weight of the sandstone, and then added to that, I'll have the weight of the mercury. Together, they're going to give me the net weight downwards, which is the net force going down on the ground. All right, let's look at what the problem gives me. I have the density of sandstone up here. I have the diameter of the block, and I have its height. So its height is 0.25 meters or 25 centimeters. I know the diameter of the pool of mercury, so that means I know the radius, and I know the height of the pool of mercury, so I can figure out the height of it. And of course, I've got the density of the mercury. So all that's listed over here on the left side under the givens. All right, so where do we start? Well, let's start with what we know with the mass. We know that mass is equal to density times volume. So weight is equal to mg, that's our old equation. If I replace the mass with density times volume, then I get rho vg. So the weight is just equal to rho vg. So to figure out the total weight, I've got to find the weight of the stone plus the weight of the pool of mercury added together. So I'll use rho vg since they give me the density. If they gave me mass, I would use mg, but they gave me density. So I'm going to use rho vg for the stone and then rho vg for the pool of mercury. So the total weight is 2710 kilograms per cubic meter times the volume of a cylinder. So remember, the volume of a cylinder is just the area underneath it times the height. So the area is equal to pi r squared times the height. So radius squared times pi times the height that they give me. And that's what this is. Pi r squared times the height. And then for the pool of mercury, pi r squared times its height. When I do the math, I get 92,250, which with 3 sig figs, 92,300 newtons.